Hello everyone. So in this video we will discuss about the current transformer. Okay, these are current transformers. You can see the ratio also. For this particular one it is 50 by 5 and our power frequency of 50 Hz, and then the instrument safety factor should be less than 5. Okay, what is this ISF, instrument safety or security factor? This is nothing but the ratio of the maximum limited current by divided by the rated current. Okay, this limited current, the maximum limited current is on account of maybe due to fall or something, right? For example, if the fault current is 5000 ampere and then your rated current is 1000 ampere, in case you take a CT ratio of 1000 by 1, then in that case your ISF value is 5. It should not be more than 5, because if it's more than 5, in that case the CT core will get saturated, and in that case the secondary current will be 0, and that case you will not be getting the the readings. All right, so normally we don't use CT, okay, in our measurement of power or voltage or current, or to be precise the energy consumption. We don't actually use CT in smaller loads, for example. But nowadays people are using, or they are applying for say 10 or 20 or 30 kilowatt. They apply this as their connected load, and then, or we say, contract demand nowadays. And because of the increase in load, and then correspondingly also there will be increase in current, right? And because of that we cannot measure directly the current, because current sometime will be 30 to 40 amperes. That will be too high for a meter, because most of the time meters are of rating 1 ampere or 5 ampere, or up to maximum 10 ampere, right? So we cannot feed directly these high amount of current directly into the meter. The meter will get burned. All right, so in order to protect the meter or to measure the energy in those cases, what we use these current transformers, the CTs. But how do we choose CTs? Okay, we'll have to calculate the connected load. For example, if I take, let's say, one consumer is having a connected load of say he's having connected load of 25 kilowatt or 30 kilowatt. In that case, if you calculate the current, taking the power as 30 kilowatt, and then you use that formula of √3 VLIL cos phi, and you take a power factor of say 0.9 something, and then if you calculate the value of current, it will come around 26-27 ampere, which is too high to directly measure this current. So what we do, we use these CT. All right, so this is why CTs are important in measurement. All right, so you see this is 50 by 5 ampere. This is used in if we have a connected load of 20 to, or we say 10 up to 30 kilowatt, we use this CT, okay, of ratio 50 by 5. And if our connected load is and we have to calculate, actually, if our connected load is around 80, we then use 100 by 5. And if the connected load is around 130, 140, then we use 150 by 5, or if more than that, then we use 200 by 5. That depends on the connected load. All right, you see there is the ratio. It is understood, and the class is of accuracy is 0.5, and then the ISF is also understood, and this the Borden is 5. Most of the time the Bordens of all the current transformers are 5 volt ampere. The Borden 5 ampere, and this is our recent time. You can see it's very good. The primary S1 S2 or P1 P2, we say the primary, this is connected to primary P1, and then P2 like this. It will go like this, and the secondary S1 S2 like this. Secondary is a single coil. All right, and then these are the two terminals. It looks very good, but the only thing that it is not very, the insulation, it is of recent cars. It become brittle after a few years of using this. Okay, that's why it's not very, the cover, the cast is not a very good one. And this is a 50 by we use in all. I'll be showing you in a separate video how this is the connection is done. Okay, and then we'll see the other CT also. This is 50 by 5. Let us go to 100 by 5, how it looks like. So this is the fifth. This is what is the ratio? It's 100 by 5 ampere. All right, is current transformers, and the manufacturer is Kappa Electrical Private Limited, Bangalore. All right, so here the ratio is the only friend with the previous one is the ratio 100/5, and this is also, I mean, depending on your connected load or your demand, you can calculate accordingly. Take the demand and then as P, and then you use the formula VL to 3 VLIL is equal to cos VLIL into cos 5. Then accordingly you will be getting the current. If for example, if your current value using that formula is around 83, 84, and then you can use this CT of current slightly higher than 85, 86, and then you can use this. All right, you can use this in your this is a ring type. The conductor will go like this. It will be your primary, will go like this. It will go P1 first. It will enter P1 from the supply side, and it will leave P2. All right, this one P2, it will enter from here and it will leave P2. All right, and this are the secondaries. The red and black one. Red one indicate S1 and the black one indicate S2. All right, these are the secondaries, and this is important for polarity, because unless you connect with the in the right polarity, you will not be it will not be safe for the meter. Also, you may get burned if your polarity is not correct. All right, so this is 100/5 ampere, and then we have the 150 also, 150/5 also we have, but if I have with me that or not, okay, I'm not sure, and we'll see another one. Maybe it's a 200/5. All right, it looks like this. Okay, not very clear. Yes. All right, this is another one. It is a ring type. It's very good. The Standard Gold company, Standard Gold Electrical Private Limited. Okay, it is a 200/5 the ratio. All right, and the power frequency, the button is also same. The button is 5 VA, and the class is 1. Okay, so this is P1, mean it will be from the supply side. The conductor will enter from here and it will leave this P2 like this. Okay, this will be P2. Okay, this is P1 is here and P2 is here. Actually, they have removed the cover, so this is a 200/5, and this is S1. The red one is S1 and the black is S2. It's also very solid, very good. I don't have with me the the 150/5, but we have different depending on the current, the current that you calculate on using this formula, 3-phase power P is equal to √3 VLIL, because most of the time, since we are dealing with LT metering, then root power will be your connected load. You can take it, or your demand, whatever is the case, and then √3 it's just a factor, and then VL you can take is a line voltage. You can take 415, and IL is what is to be calculated, and then you can take power factor of 0.9 or 0.85, whatever is the case. So this is how you calculate, and these are also very good. These CTs are very good. I recommend this for using indoor or outdoor. It's quite big also, and we have these 300 250/5 also, and then 300/5 also. Most of these companies with more connected load, they'll have to use CTs of higher ratio. All right, they may be using 300/5 or 500/5. That depends on the you cannot use for example, if our connected load is the consumer is having connected load of just 30 kilowatt, you cannot use this 200/5. All right, it's not that we cannot use, but then it's better to use 50/5, 50/5, because if you use this, then the accuracy will get affected, right? You will not be getting the right recording of energy meter, right? So it's better to this is how you calculate what is the CT ratio, how you select the CT ratio. It is actually based on the connected load or your contracted demand. All right, and this you can do correction from time to time, because the consumer sometimes they enhance their load also. I mean, if that is the case, then you'll have to change the CT also from time to time. I mean, that's why we say that the electrical engineering is a very dynamic system. You have to keep changing every now and then to match with the load. All right, so this is all about today. So thank you.